Thank you. Let's see if it works. Perfect. First of all, I'm very impressed with the previous presentations today. So just to give you an idea, I've been working on digitizing construction since 2004. And I'm really impressed with the speakers from Estonia, Latvia, and now also from Ernesto's with BIM Solutions. They know what they're doing. And I've seen this in many, many years. So listen carefully to what they have said, download the presentations, carefully study it, and follow their advice. I think it's really, really good advice. I'm here with my colleague Edmi, and we're about here to talk about what we do. We provide some of the solutions that Ernesto was showing previously. We're a software development company, but we're not going to talk about those solutions. We're going to talk a little bit more general. And in 2005, I was in Maastricht in Europe, listening to a talk. And I was told, this was my first sort of array into the construction industry, and I was told that the construction industry has 3 Ds that describe it. The first one, it's dirty. Okay, so the construction industry is dirty. The second one, it's very dangerous. Okay, I can sort of understand that. We're doing with big machines, things can happen. There's, gardens around any construction site to protect other people from coming in. The final D, I still cannot remember, but I'm wondering if you agree with me if I say it's digital? No, not yet? Okay, let's get it there. That would be good. The point is that 40% of the world's pollution comes from the construction industry and the way we build things today. And I don't think any one of us thinks that's a sustainable option going forward. So we need to change that. This is a picture taken by one of my colleagues who was at a conference in the US. This is Florida. It looks nice. He arrived at the hotel, was going to like a construction conference the next day. And he took this picture and sent this to his mom. And, look where I am. It's very nice, blah, blah, blah. The next day, the mother took this picture from her TV. So the whole conference had to evacuate, and luckily everybody got on their plane, got home safely. He could go to his mother and say, I'm here, nothing's happened. But that told me that this climate problem that we're seeing is closer to home than I would really had hoped. So we have to do something about this. Just another perspective on this. Does anybody know what this is? This is a picture of you if you lived in the 1990s. It's called a pale blue dot, and you can find it right there. And it's a picture of Earth about 6 billion kilometers out, so a little bit beyond Neptune, taken by Voyager 1 on the 14th of February 1990. It's a picture of us. Everyone you have ever known or read about lived or lives there. So this is a precious thing that we need to take care of. I think it's kind of beautiful. The beautiful mountains of Georgia is amazing. And we need to get to 100% sustainable state. So our mission as a company is to help our industry to get to that 100% sustainability point. And I think we all need to contribute to get there. And our belief is that digitization is the path to get there. This is a quote from Leonard Cohen. There's a crack in everything. That's where the light gets in. So the idea here, at least my interpretation of it, is when you have something that's not working perfectly, that's where you get some light in to shine on it. And that's where you can see new opportunities and new innovations. So for us, openness has become a really important ethos. So our company, The Open Way, really pushes the open standards and open way of communicating. So every single speaker today was talking about this. Having collaboration internationally, using open standards, having open or accessible BIM information from everyone, for everyone. Otherwise, it doesn't really make any sense. So when you're trying to build something like this, we all see it's kind of complicated, or something like this. Traditionally, we've been using this, and this sort of new modern technology to kind of manage this. I don't think it's going to work in the long run, so we need something more interesting. And so what is digital construction? I'm going to take you on a little thought experiment. So try to imagine, or before that, the digital construction is a lot about process. This was talked about earlier today as well. So you have something over here, and you want to build on that to get to something more beautiful over here. A really nice butterfly at the end of your project, something that you can give to the owner that he can use and manage the building with. That's the key. So it's not about just you here and now. It's about thinking about the whole process and making sure you build on something. But let's do the thought experiment. So imagine you have a drawer. That's an imaginable drawer. You can put whatever you want into it. So let's take a window. You take a window and you put it into that drawer. And then you take some documentation about that window, put it into the drawer. And then maybe you have some tools you use to clean the window with. You put it into that drawer. So everything related to that window is in this drawer. So when you need it, you just go over here, you open the drawer, and then you can find everything you need about that window. If you expand this a little bit and you say you have a bunch of sections of drawers, so you can have a bunch of drawers for a window and everything that's related to that window. And then over here you have a section of drawers with doors and everything related to that doors. And then you expand it a little bit and you put some geometrical information here. So how does that drawer or how does that window or door look like? How wide is it? How big is it? What color has it? And then finally you add some location information. So where is this window or door? And when you put it all together, you get a building information model or a digital twin or whatever. So this is what we're talking about. And then you have the architect over here making some kind of information about the drawer, the doors and the windows. And then you have the electrical engineer here saying something about, well, if you're going to have an alarm on that door, I need some kind of electricity going there. And over here you have the HVAC engineer saying you want a fresh air in there or whatever. And all this is made independently but put together in a federated model that we heard earlier about. So that's essentially what digital construction is all about. Computers can handle this very nicely. So it's hard to see, but this is a perfect digital model or a digital twin. Everything you want to know about it is here. It's in a computer, so you can just click on this, and boom, you get all the information you need. If you're in the early design phase, if you're in the construction phase, if you're in the maintenance phase, you always get exactly the information you need in order to make good decisions. So that's opening your mind a little bit about the imagination or all the possibilities that you have when you're using these tools. And don't worry about all the data. Today, there is 64 zettabytes of data online, the internet. And that's about 64 trillion gigabytes, if that helps you to visualize the size of this number. I have no clue, it's too big. But you're using a small, simple device, not so simple, but a small device to access all that information. So if you put everything you know about a building or a built asset, bridge or something, into a computer, don't worry, the software should handle that for you. So you should just dump all the information you want and need at any given time in there and have the software filter that out for you just like you do today when you surf the internet and use this for your own purpose. So again, open access to information is key to make sure that you benefit all the way. And as we heard earlier today as well, the industry is very fragmented. There are a lot of different actors that all wants to do the same thing, build something, but they have different opinions, different point of view, different business models, and we all have to kind of work together on this. So that's why communication is incredibly important. And we need a very clear communication so that there are no misunderstandings. also mentioned on the previous speaker from Ernesto's, you don't want a different interpretations. You want a clear visual message. You want speed. You want the communication to be almost instant, fast, back and forth, until you have iterated over it and solved it. You want everyone to have access to this information so that it's quick and you can bring in other people to shed light on it and find a solution. And you want that communication to be a reference for you later on. So imagine if you have a problem in one corner of your new building, 20 years maybe later, you have a massive problem in a corner and you don't know why. You can go back and look at all the communication and see if there was something going on in that corner during the design and construction that now sheds light on what you're dealing with. So the whole idea is it's a process. You start early on when you start thinking about this as a new project. You want to go all the way, but you want to build and build and build or add information until you get this beautiful butterfly that can be used later on in that process. And with that, I'm going to give the floor to you, Edmi.
Thank you. And now with this beautiful butterfly, we're going to do some smart building. So a smart building is the word that we use when you're using innovation and technology into your building to monitor data to take better decisions. So there are two important reasons to do it. First, it's like we're spending 90% of our time in a building. It could be at home, university, hospital, whatever. And the second one, it's construction. It's 2 to 3 years, maybe 5 years. So as Ernesta said, you're spending 25% of your budget on construction, but maintenance, it's more like 20, 30 years, or even 40. So you really need to focus your time and energy on maintenance. Is it also the reason how we can have actually a bigger impact, how we can reduce carbon footprint and we can save energy? So that's the other reason, is to go to a more sustainable industry. And in major cities, it's only 10% of new constructions. So the rest of the construction are already built buildings. So we really need to focus on it. And as other speakers said before, today there are new technology that make possible to do even BIM project management on existing building, even really old one. So to do that, how we can do actually smart buildings? So the first thing is to aggregate data. So to do that, the best way to do it is to use a BIM assets management software. So you can use any software that you want to actually be able to use all of this information that you did during the design and construction phases, or also after that when you collect or digitalize existing buildings. And then you're using assets management software to bring all the information together from your building. It could be from models, it could be from documents, data sheets, facility management system that you have already in place, or it could be also from the connected part like BMS, IoT, other way to bring back energy consumptions or services like, for example, Outlook calendar to do like meeting room management. So the purpose of that is to bring all of this information into one software and to give a quick access to information to random people. When I say random people, it's to be able to make sure that all the technical systems that you have in your building will be accessible to the user of the building and to the people doing the maintenance. The second thing is, with this kind of asset management software, you can also do issue management. So if we take a simple use case, imagine you've got the light fixture doesn't work in a conference room. So the user can just directly go on the platform and then do a ticket, and then the maintenance guys will get the information. But then you get the information that there is an issue, and then you will go on the platform and will find all the information about this light fixture. It will be able to actually order the right piece of equipment and then go on site and do the intervention. Then you're saving a lot of time, energy, and money. It's pretty simple. To do that, that was the what. So we need to do smart building. How we need to do it, the best way is to use softwares at the end. It's like, so the best way to see and to collect all of the information. And we're doing it for 3 major reasons. First one is to streamline facility management. Second one would be to increase space management, and the third one would be to decrease energy consumptions. So those are average numbers. But if you streamline your facility management, as I said before, like if you're able to schedule your intervention better, if you're able to know the intervention before going on site, you can save up to 50% of your budget per year. If you're having a better space management, so for example, if you're able to rent your building more, your offices, or if you're able to follow the lease, you will go up to 10%, and if you're saving energy, it will be an average of 50%. So if we're taking those numbers and we're trying to apply to a real case, so I took a building in Paris, so it's my hometown, but we can do the same thing here. Just it will be slightly different for the number, but the range of values will be the same. So let's take an office building in a big city. So you've got maintenance cost, it's around 20 euro per square meter per year, 2025. So per year will be 70,000 euro. Let's take like the average rent in big city, around 300 euro square meter per year, so it's a little bit more than 1 million revenue per year. And if you're thinking about energy consumption, electricity and hot water, electricity including air conditioning and heating systems, it will be a little bit less than 800,000 euro per year. If you're using, I'm not saying that if you're using the software, but if you're using the entire BIM project management to do from the beginning till the end, and then using the right tools to use those information that you collected from all of the stakeholders, then you will be able to save the number that I just told you. So if we take the 50% on facility management, it will be a little bit more than 10,000 per year. If we increase 10% property management, it will be over 100,000 per year. And if you're saving energy, it will be like a little bit more than 110,000 per year. Imagine that on a building, it will be a little bit over $250,000 per year, and imagine now you've got 50 assets, because you know some people, they've got some really big real estate portfolio. It's a little bit over 1 million euro per year that you can save or you can gain because you're doing a better property management. So just to show you a few of our projects that our clients are using our softwares to deal with. We've got buildings, so a pretty classical one. This one is one with the zero emission of CO2, so it's a really technical one, meaning that it's trying to fit all of the new European regulations about carbon footprint and energy consumption. This one is the airport in Amsterdam, so a really big one. Want to have a
I have a comment on this. So Schiphol Airport is a huge airport in Amsterdam. They do projects all the time. They're either changing a shop to something else, or they're enhancing something on the terminal, or they're building a new terminal, or what have you. But they know exactly what kind of information they want for every single project. They've defined a bunch of asset types, so things that you put in place, like a wall or a lighting or what have you. So when they start a project, they define what kind of asset types are going into the project. And for each asset type, they know what kind of properties they would like numbers on, and they know what kind of document types they want. All this is very defined clearly, and they give this to the project, and the projects needs to produce those data so that they can run the airport more efficiently later. I'm not saying they're getting all that information. That's difficult today, actually, but they're trying to make sure that they have a clear sort of requirement when a project starts, so that everyone in the project knows what they should deliver at the end, because they need it to run an airport like this.
Another project will be, because we talked about buildings, this one will be infrastructures. So it means that same thing, it's the metro in France, and it's for construction work, but also for operation and maintenance. This one is just to show that you can go further than infrastructures and just buildings. So it's Nordic aqua farms, Norway, Denmark, and the US. This is the first actually digital twin that we did. It's an entire net zero energy buildings, and you can also, so you can bring information into the software. You can see, for example, information from IoT sensor on site, or from energy consumption, but you can also do building automation. So you can actually monitor the windows or the shadows, or monitor like a temperature in the room to make sure that, for example, during the weekend, the temperature go down, and then when people are going back at the office on Monday, the room will be like at the right temperature, and then you're saving energy during the weekend. And this one is just to show you that we provide different kind of software for design and construction, but also for operation and maintenance. But because we really believe at Catenda that it's our technology, but we want to show other people that other people will use our technology, we've got open APIs. So for this one, for example, one of our customers wanted to have like a software to solve specific use cases. So we gave him access to our viewer, and I think it was like BCF management, like document management also, and he built his own software on top of it. So we also provide possibility to connect to our solutions.
So what they're doing here is what we saw earlier about statuses on all the single objects in the model. Yep. So what they've done here is to use our technology to bring up a visualization and connect the status of each model. So they can look at a steel frame and see, is that steel frame in production, on its way to site, is it installed, has it been quality assured, etc. So they have full control of the whole logistical operations. And in Tokyo, it's kind of narrow, so it's important for them to have that kind of information.
And so what's next? We think that in construction industry, there's a lot of things to do. There's a lot of new ideas that we can apply. We can think about artificial intelligence, for example, for planning or for cost saving or for the use of material. You can think about robots on site doing human tasks. You can think about 3D printing houses. But you can only do that so if you're using open standards, because the first thing is to make sure that you will have all your data well structured and being able to communicate to everybody and every systems using it. So the future will be like a lot of big opportunities, but it will be open.
Very good. Thank you.